In this tutorial, I will be teaching you about Python function, but not with any generic example which looks something like this. Rather, I will be creating a function which will take a backup of a file, and this implementation will be for real project. For your convenience, I will leave all the timestamps along with necessary links in the description of this video. Feel free to check those out. Now, let's start the tutorial. What's up internet, I am Manish from rebellionwriter.com. Welcome back once again. In this tutorial, you are going to learn how to create functions in Python, the concept of default arguments, because that's what we need in our project, how to copy a file using Python shuttle library, along with how to import and reuse this function in our project. It's important. I'm going to implement this function as a standalone block in its own Python script so that I can reuse it. But before we further indulge into this power pack tutorial, I just want to ask you to subscribe to the channel if you haven't already and press the bell icon to get notified every time I upload a new video. Also, press the thumbs up button if you like this video and share this video on your social media with your friends. Now, let's quickly set up the project. For the demonstration, I will create a folder here on my desktop and I will name it File Ops. Done. Now this folder will work as our project directory. Next, I will open up the editor. For this project, my choice of editor is going to be the Spider, but you can use whatever editor or IDE you have. Done. Now I will create a file and save it in our project directory. Let's name it file_bkp.py. This file is going to contain only our function, nothing else than that. Now before I start writing the code, let me quickly explain the syntax for creating a function in Python 3. If you already know it, then feel free to skip this portion. Like every other programming language, functions in Python are made up of three parts: function signature, the function body, and the function call. In Python programming, function signature starts with a keyword def, followed by the name of the function. You can name your function whatever you want, except the reserved keywords. And then we have parentheses. Inside those parentheses, you can specify parameters of your function. A function can have 0 or more parameters. And in the end, we have colon. This colon specifies the end of function signature. After that, we have the body of the function. Function's body contains executable statements. Unlike other programming languages, in Python we don't enclose the body inside curly brackets. Rather, we use indentation. By indent, I mean at least 4 spaces or single tab. Always make sure to indent all the statements that you want your function to execute at the same space. Right in front of you are two wireframe examples. One is showing you the correct way of defining a function, whereas other is showing the wrong way of defining a function. I think that's enough of the syntax. Now let me explain the project that we are going to do today. Let me quickly brief you about today's project. I recently uploaded a video on data analysis of coronavirus data. If you haven't watched it, links are on your screen as well as in the description. Anyway, in that project, we collected the data from Wikipedia using a technique called web scraping. Then we cleaned it using a library called Python Pandas. In the end, we exported that data in Microsoft Excel file. The Python script that we created there will perform all these actions every time we execute it and update the data with the latest info. And that is the problem. Every time you execute the script, it takes the data, cleans it, and exports it. And that export updates the previous file without saving it. This means we completely lose the previous day's data. So what I want is this script that we are going to create today to take the backup of the exported file before updating it. And here is how I am planning to do it. To perform a backup, I will be creating a function which will copy the source file and paste it to a location. This location could either be the project directory or a remote location. Let's call the file whose backup we are performing the source file and call the backup copy the new file. Anyway, this function needs to fulfill three things. These are: it must be a standalone block so that I can use it not only with this project but also with my other projects. Location of source file and the new file must be dynamic. I'll explain this in a bit. This function must add the date in the name of the new file, which is the backup copy of the source file. By doing so, it will become much easier for us to retrieve the data of a specific date. Now, let's talk about the problem of this function, which is the location of files. To ensure the reusability of this function and to future-proof it, there are 4 use cases that we must consider. And these are: the source file is located in the project directory as well as its backup copy is also getting created in the project directory. Second, the source file is in the project directory, but user wants to create its backup copy at a remote location. The source file is located at a remote location and user wants to make its backup copy in the project directory, or the location of both source file and its backup copy is at a remote location. If we would be writing this function in some other programming language like Java, then we would have to tackle these use cases with the help of function overloading. We simply have to create 4 copies of a function with same name but with different arguments. However, in Python, we don't have this concept of function overloading. But with Python, it's much easier to deal with these 4 use cases. Because here, we won't be coding 4 copies of a function. Rather, we will be writing only 1 copy of a function to deal with all of them. Let's write the code. Here I will aim to make this script as flexible as possible. At the same time, I will try to create this script as easy as possible way. I promise no fancy Python stuff. So let's do that.
Okay, here we are. Let's quickly delete whatever we have in this script and clean it. Done. Now let's start writing the definition of our function. Here we have the definition of our function. As you can see, I have named this function take_bkp and it is accepting 4 parameters. These are source file name, backup file name, source file location, and backup file location. From the perspective of flexibility, there are so many things that are wrong with this function definition, but we will worry about them later. Let's first simply code this function to fulfill the basic functionalities, which are: take the source file and copy it, create its backup copy, save that backup copy with a specific name, and by specific name I mean add the date in the name that user has specified for the backup copy, like this. So let's code that. Issue number 1, file names. To access the file, we need a proper URL, which looks something like this. But in our function, we are accepting both the file location and file name separately. Therefore, to access them, we first need to concatenate the file location with file name. Let's quickly do that. Source file name is fixed, but the backup file name is not. This statement will create a backup file with a simple name without adding a date, but we want to add the date before the name of the file.
The idea is to run this function right after updating and exporting of the coronavirus data. That way the updating and exporting of the data and the backup all are happening at the same date. That means we need to add the date of current day in the name of the backup copy. And for that, we will be using the datetime library of Python programming. So let's do that.
Instead of importing the entire package, we are only importing the date class. This statement will fetch today's date and save it into the variable which we named as today. Now we will format this date. For formatting the date, we use strftime function. On execution of this statement, we will have today's date in this format. And if we will add this date to the file name, then it will look like this. To achieve this, we just have to concatenate the string that we have saved in the variable date_format with the bkp_file, like this. Great, we have sorted the names. Now we will code the last functionality of this function, which will be creating a backup copy of the source file. To do this, we will use a function called copy2 of shuttle library. Let's do it. First, we will import the library. Now let's call the function. This function takes two parameters. First one is the source file location with the name or just its name. Second one is the location with the name of the backup file or again just its name. In our case, these two parameters are our variables src_file and bkp_file, like this. With this, we have successfully coded our function. Before that, I think I should also add a print statement with a success message in the end of our function, like this. Done. Now let's execute and see whether we have any error or warnings. Done. Everything is good.
We have successfully coded the function with its basic functionalities, which means if we run it right now, it will take the backup of a file, but it's not reusable. Since all its parameters are mandatory, thus it's next to impossible for us to reuse it. Even if we want to, then we would have to recode this function according to the project. Also, remember those 4 use cases that we discussed earlier? In order to fulfill them, we need to figure out a way to change the behavior of the parameters of our function from mandatory to optional. So let's make this function fit for reusability, and we will start with the name of the backup file, which is the second parameter of this function. Let's do that. There are 2 use cases with it. First, when user wants to save the backup file with a new name. Second, when user doesn't want to save the backup file with the new name. Let's say user does not want to give a new name to the backup file. He or she just want to append the date to the name of the source file and use it as the name of the backup copy. We can achieve this functionality using default argument. Using them, we can set a default value for the parameter of a function while declaring it. In case user did not specify the value for the argument while calling the function, the compiler will use this default value. Let me show you how we do that.
Here is our function. I'm going to modify it a little bit, like this. Here I specified none as the default value for the parameter bkp_file_name. None in Python is a keyword which is used for implying null values. Now, if we do not specify any value for this parameter, the compiler will use none. Anyway, using this default argument, we have made bkp_file_name an optional parameter. But this does not solve our problem. Now we need to deal with this null value. Let's do that. If user did not specify any value for the parameter bkp_file_name, the compiler will use the default argument, which in our case is none. That default argument will trigger this if-else condition. As you can see, in the if block, we are checking if the value stored in parameter is none or not. If it is none, then there are 2 statements which will run. In the first statement, we are simply storing the source file name into the bkp_file_name parameter. In the next statement, we are appending the date to that name. This way, when not specifying any value to the parameter bkp_file_name, the name of the source file will be used in our desired format. But if user assigns a name to the backup copy, then else block of the statement will be executed. And on its execution, the compiler will take that value, append it with the date, and use it. That solves our problem. Now let's move on to the next one, which is related to the location of the files. Remember those 4 use cases that we talked about earlier? It's time to deal with them. The solution is very simple. We just have to assign an empty string as a default argument to our last two parameters, which are src underscore file underscore loc and bkp underscore file underscore loc, like this. That's it. With this, we have successfully coded a function which we can reuse with any of our Python project. Now, let's test this function and see if it is working or not. Before we test our function, let's quickly see what we have in our project directory. There you go. Here we only have the script that we just created. Now, I'm going to paste the script that I created in the last video right here in our project directory. You can download this script from my GitHub page. Link is in the description. Okay, just let me paste that script here. Great. Okay, now we have two Python scripts in our project directory. Let's test this function. To test it, we will open up the second script. Here we go. Now we will call the function take underscore bkp in this script. For that, first import the file that has our function. In our case, the name of the file which contains our function definition is file underscore bkp.py. Write an import statement like this. Now you can use all the contents of this file here. Just make sure both the script, the one which contains the function definition and the one in which we are calling the function, are in the same directory. Now I want to call our function take underscore bkp right before exporting the data, which was the last step on this script. And here are the statements for exporting the data. We will call our function right before them. First, I will create a variable with the name src underscore file underscore name. In this variable, I saved a string COVID-19 underscore dataset.xlsx. It is actually the name of our source file. For the time being, this variable will be enough for testing our function. Now, I will call our function. Done. Now let's execute this code and see what we have. But first, I need to fix a mistake that I did while creating the function. We don't need this statement because we are handling the name of the backup file using the if-else block. So we will be going to delete it. Done. Now let's come back to the script and run it. Okay, here we are. Let's run it. Fine, we got an error because our function call tried taking a backup of a file COVID-19 underscore dataset.xlx, which does not exist. If you take a look at our project directory, you will find that we still have our two Python scripts in it and nothing else.
Anyways, what just happened here is that we executed the code. Everything worked fine until the function call. As soon as interpreter called the function, it encountered an exception. Because our function call tried to take a backup of a file which does not exist. And right after that, compiler quit the execution and did not execute the remaining statements. In simple words, we got an exception. And to deal with that, now we need to write an exception handling block. So let's do that.
So if you read the error carefully, then you will see we got file not found error. Let's handle it. Here we have a very simple try and accept block. Inside the try block, we have our function call. And then we have accept block. In this block, we are handling our file not found error. Now on execution, if we have this error, then our program will print the underlying statement and move ahead instead of coming out from the program flow. Let's run this program and see the result. Great, no error this time, though we got our string printed here. Now let's again check our project directory. This time we have three files here. This third file is created by our data analysis script, and this is the source file which our function is looking for. Now, if we will again execute our code, then this time we should have a backup copy of this file created in this directory as well. What do you say? Shall we try? Let's do it. Here we are. Let's execute the code once again. Great, execution done. This time we have a backup successful message. Let's check the project directory and see if we have our backup copy created or not. Here is our backup copy with the formatted name, just like we wanted.
Let's run one more use case. Suppose you have your source file located in your project directory and you want to save its backup copy at some other location. Let's do it.
Let's create a subdirectory right here inside our project directory and name it backup. Now we will save our backup copy inside this subdirectory. For that, we need its location path. Let's quickly copy it. Done. Now let's get back to the script. Here I will create another variable and store the location path that we just copied in that variable. Now, here you need to take care of two things. First, all the slashes that this path contains must always be forward slashes, like I have here. Second, make sure this path also ends with a forward slash, like this. Great, now we will use this variable as the fourth parameter in our function call. Fourth parameter. Because while declaring the function, we put backup file location parameter at the fourth place. So let's do that. Here is our function call. Since we will be using value for the fourth parameter, thus we will have to put something for the second and the third parameter as well. So in the second parameter, we will specify none. And in the third parameter, we will specify an empty string, just a pair of single quotes, like this. Now you can supply the name of the variable which holds the location of the backup file here. In our case, that variable is bkp underscore file underscore loc, like this. That's it. That's all we have to do. Let's run the code. Done. Now let's check the subdirectory that we just created. Here it is. We have successfully created a backup copy in a remote location using our function. But there is a bug in our code. Let me show you. But first, let's get back to our script. Now, let's say while calling this function, you specify an empty string instead of none to the value of the second parameter, like this. Everything looks good. Let's run this code now and see what happens. But first, let's delete the backup copy that the previous execution of this code created. Here it is. Select and delete. Done. Now let's run the code. Execution done. There is no error. We even got a success message. Now let's check the directory and see what this code created. Here we are. As you can see, we got a file created, but in a manner which we don't want. Silent bugs that raise no errors or exceptions but produce completely wrong results are the most dangerous ones. That is why I always do random use case testing before deploying anything. Anyway, let's fix this bug. Here we are. And here is the script that has our function. Fixing that bug won't be difficult. We just need to add an OR condition in our if clause, like this. This not bkp underscore file underscore name condition will return true only when there is a string stored in the variable. Otherwise, it will be evaluated as false. This should solve our problem. Let's run the code again and see if it works or not. Here is the script. We are not changing anything here. Let's run it. Execution done. Now let's check the directory. This time here we have two files. This one is from the previous execution and this one from the latest execution. Seems like we have successfully fixed our bug. There is another use case where our code is failing. Suppose you have accidentally entered an empty string, but this time with more than one space. If we will keep on writing a condition for every single space, then this code will never end. To know how I deal with this use case, check out the code on my GitHub page. Link is in the description.
I guess that's it for this video. Hope you enjoyed watching. If so, then please press the thumbs up button and like this video. And if you want more such awesome informational videos which are based on real-time projects, then please subscribe to the channel. Thanks for watching. This is Manish from rebellionrider.com. Cut.